Hey everyone, it's great to see you again. We're going to pick up sort of where we left off last time when we started talking about thermodynamics, which by its name just means how to convert heat into work. And last time we talked about the first law of thermodynamics, which is just a statement of conservation of energy. It says that if you, for example, you want to increase the energy of some system, you can either do work on it or you can just let heat flow into it. Or conversely, if you have some energy, that energy can be used to do work or to produce some heat, basically. And today I want to discuss something, maybe a very common example of that, which is how an engine works. So I happen to have a nice model of such a thing here, of one of the pistons in your car, and we can imagine that I've just let air into this piston, and because the wheels are going around and the piston is moving, I'm going to compress that gas. I've let the air and the gas mixture in, and when it gets compressed enough, then what's going to happen? Well, the spark plug is going to go off, and that's going to ignite the gas. Okay, so I have kind of a fun demo associated with that. So I have some gas, in this case ethanol, not actually gasoline. And I'm just going to put a little bit in this film canister, just a couple of drops. And now I need a spark plug, so that's going to be this kind of fun device here that we'll talk a little bit about next time. So if I push the button, you can see I get a nice, beautiful spark across that. And I'm just going to put this on and seal it up. And next we're going to go into my basement again so I can set this off someplace where it's a little safer than in my dining room. So I'll see you in just a second. Hi again. Okay, we're now in my basement and I have my little popper all set here. I'm just going to push the button, make that spark inside, and we'll see what happens and we'll hear what happens. Okay, very loud. Now we're going to go back upstairs to my kitchen. Okay, we're back. So what we just saw is that when I let that spark plug go off, that causes an explosion, and then that hot gas pushes the piston down. There's a lot of work on the piston, and then we actually open the valve and get rid of that hot gas. It's pretty easy now to do the compression back up because of the fact that I'm getting rid of the hot gas and I'm letting in cold gas, and so it's a lot easier to compress. Okay, so let me just go to a slide so we can just quickly see how efficient these things can be. So typically we can describe this type of process in terms of what happens for the pressure of the gas and the volume of the gas. So that's what these plots are showing. This is where I first let the fuel mixture in, the air in, when I'm compressing it when it's pretty cool. And then in this next stage, we have in this next stage here, we have when the gas is combusted, when it ignites, the pressure builds very rapidly to a high value, and then finally the piston is able to expand and I get work out of the system. So if you analyze this, you find that the amount of work that you can get out of that engine is just equal to the area of this crosshatch section. And so you could then ask, well, how could I make my engine more efficient? How could I get more work out of it? And I guess it's pretty clear. For example, if you could get either the bigger volume to be bigger or the smaller volume to be smaller, then that would give more of this hatched area that allow me to get more work out. And in fact, that ratio of the big volume to the little volume, that's called the compression ratio of an engine. And here's a typical example of what the efficiency might look like as a function of the compression ratio. So the bigger the compression ratio, the bigger the efficiency. That then leads us to ask, well, what's the limit to the compression ratio? Why can't I just get a very efficient engine by making a very big, large volume or a very small volume? And so on the one hand, the big volume becomes sort of impractical because if the volume is too big, I basically then have this huge engine block. On the other hand, we can ask, well, why can't I make the volume really, really small? And the issue with that has to do with the demo that we did last time with the fire starter. We said that when I just compress the gas in here a lot, the temperature goes way high, and then I was actually able to light a piece of cotton. If instead I had a gasoline mixture in here, if the pressure gets too high, the temperature gets too high, and the gasoline on its own will ignite, even before the spark plug will get a chance to go off. That's what happens if you have knocking in the engine. If you have a diesel engine, actually, they don't even have a spark plug. It's the compression of the gas itself that causes it to ignite. But let's go back to a regular gasoline engine and ask, well, how might I be able to get that volume to go even a little bit smaller? And I'll just go back to my screen one more time. It turns out that if you have gas that has a higher octane, that has also a higher a higher auto ignition temperature. It means that you can get that gas to a higher temperature before it will on its own ignite. And therefore, that means we can compress it to a smaller volume when the temperature is higher before it ignites. That means I have a higher compression ratio, and that means I can have a higher efficiency. Okay, so that is an explanation, at least, of roughly how our gasoline engines work. Next time we will come back and try and explain how this fun thing works. Okay, hope you guys have a great week. Bye-bye.